Here we have 5 shapes, and of these shapes, 3 of the 5 shapes are white squares. So the probability that Jasmine picks a white square is going to be 3 out of 5. So in other words, I would expect her to get a white square 3/5 of the times that she does this experiment. So if she does the experiment 150 times, I would expect 3/5 of 150 times for her to get a white square. So 3/5 of 150, if you like, 1/5 of 150 is 30, so that's going to be the same as 3 times 30, and 3 times 30 is 90. Another way of doing that is to think of 3/5 as a decimal. You can change it using a calculator if you like, and if you do 0.6 again times 150, you will again get 90. So I'd expect her to get a white square about 90 times. Okay, right. We now have 2 people, Alec and Bashir. I'm going to call them A and B. So Alec I'm going to call A, Bashir I'm going to call B. And they're taking, first of all, Alec takes the shape. Very important this, he does not replace it. So once he has taken a shape, there will only be 4 shapes left. That's very important. Okay, first of all, we're looking at the probability that both take a square. And I think a tree diagram helps here. First of all, let's have a look at the choices here. So basically, if we look at Alec first, he could get a square or not get a square. And the probability that he actually gets a square, well, if you look at the shapes, 4 out of 5 of them are squares. So the probability that Alex gets a square with his first pick is 4/5. So this is Alec. Okay. He then keeps that square. Okay, and that's crucial. Okay, let's have a look at Bashir. He could now get a square, or he could not get a square. I'm actually not really interested in the rest of the tree diagram. It is totally irrelevant because the question's saying what's the probability that they both take a square. So I'm actually only interested in these branches here. Now, if Alec has taken a square, okay, that means that there are only 3 squares left. So Bashir is choosing, and it also means that there are only 4 shapes at all. So there are 4 shapes left once Alec has chosen his square, and of those 4 shapes, only 3 of them are squares. So the probability that Bashir now gets a square is only 3/4. Now we always multiply along the branches. So the probability that both of them get a square is going to be, 4/5 multiplied by 3/4. Okay, now we can cancel the 4's there to give us 1 and 1. In other words, the probability that both of those take a square is actually just 3/5. Okay, right. Taking shapes of the same color, a little bit more complicated this. Again, instead of choosing square and not square this time, our choices for Alec, so that's person A, he could get a black or he could get a white. And those are the only options which are open to him. Okay, so if we look back at our shapes, 2 of them are black and 3 of them are white. Okay, so the probability of getting a black is 2 out of 5, or 2/5. The probability of a white is 3/5, and that's for Alec. Okay, now along comes Bashir. He could also get, I'll just write BW this time, he could also get a black and a white, or it could be that if Alec got a white, then again Bashir could get a black or a white. And let's have a look at the probabilities. Again, we don't need all of them because the question is saying what's the probability that they take 2 shapes of the same color. So I'm actually only interested in either Alec getting, that should be a B, either Alec getting a black and Bashir getting a black, or both of them getting a white. So I only need to fill in the probability here and here. Okay, so Alec has taken out a black. There were 2 blacks, which means that there's now only 1 black left out of a possible 4 shapes that Bashir is going to choose from. Okay, going this way, Alec has chosen a white. So there were 3 whites. There are now only 2 whites left, again out of a possible 4. Now again, we're going to multiply along the branches, but we're only going to multiply along here. So the probability that they both get a black, so let's say black, let's call it the probability of BB, is just going to be 2/5 times 1/4, and 2/5 times 1/4 is just going to be 2/20. Okay, could simplify that. If we go along this route, the probability that they both get a white, well, that's going to be 3/5 multiplied by 2/4, and again, if we multiply 3 times 2 is 6, 5 times 4 is 20. That's the probability that they both get a white. Now the situation here, we always add going between the branches, or another way of remembering that is either they get 2 blacks or they get 2 whites, okay? And or in probability language always means add. So to find the final answer, I'm now going to do 2/20 plus my 6/20. Okay, so I'm going to add this one and this one, 2/20 plus 6/20. We just need to add the tops, so that's 8, not the bottoms though. 2/20 plus 6/20 is 8/20, which is the same as 4/10, which actually simplifies to 2/5. So the probability they both take shapes of the same colour is just